All right, so this is the second video to finish our Capstone Review A. So we're on question number 7, and that's asking us to simplify this rational expression. So to simplify, we're looking for common factors in the numerator and denominator. So I can't find any common factors until I have factored. So I'm going to start by factoring 3x squared plus 11x minus 4. I'm going to use a factor x to help me do some thinking here. Since there's a leading coefficient of 3, I do want to multiply the first and last terms together and find two numbers that can multiply to give me negative 12x squared and combine to give me 11x. Okay, so 12 times 1 gives me 12, and I can make an 11 out of those as well. I would need a positive 12 minus 1. Okay, now I'm just going to, if you need to do this the long way, by all means feel free, but I'm going to go ahead and draw two parentheses here and just start thinking. To get this first term, 3x squared, I know I'm going to need a 3x times x. And now I know that when I'm starting my other thinking, I know that one of these has to end up giving me a 12x when I multiply by something like this 3x times something. And when I multiply this x times something, I need to come up with a 12x and a minus 1x. Okay, so 3 would have to multiply a fraction to get negative 1. So this 3 is going to figure out what does that need to multiply to get 12. That would be a 4. 3 times 4 gives me 12. And since I need it to be a positive 12, I'm going to put the plus 4 in there. Which means to get my minus 1x, I'm going to need this to be a minus 1. Okay, so this factored is just 3x minus 1 times x plus 4. And like I mentioned, if there are other strategies you want to use to factor this, by all means do it. All right, to factor the bottom, I notice these two have a GCF. There is a greatest common factor of 8. You can divide 8 evenly out of both of these terms. Okay, so if I pull the 8 out to the side, I'm just going to think 8 times what gives me 8x, and 8 times what gives me 32. Okay, so now that I have it completely factored, now I'm ready to do some simplifying. The only common factor is x plus 4. So that can simplify and become a 1, which means my simplified fraction is 3x minus 1 divided by 8. There is nothing else I can do to simplify that. Okay, on to question 8. Simplify the expression completely. So this time we are multiplying two rational expressions together. And the same thing we did in step 7, or in question 7, we want to do in 8. We want to factor everything completely to see if there's some simplifying I can do before I multiply. Okay, so starting with this numerator, 2x plus 6, these have a GCF of 2. So I'm going to pull a 2 or divide a 2 out of each term and come up with 2 times the quantity of x plus 3. All right, now on to the bottom fraction. Choose a new color, x squared plus 4x minus 5. If you would like a factor x to help you, by all means, use it. Okay, but I think I can kind of think backwards here. To get that first term, x squared, I know I need x times x. And the two numbers I can multiply to give me negative 5 and combine to give me 4 would be 5 and 1. And to make that positive 4, I'll need a positive 5 minus 1. Okay, we'll notice this guy over here, oops, there's our multiplication sign. This guy over here, there's nothing I can do to factor that. It's just x minus 1. And this last guy, 10, right? Not much you can do. But since I'm going to be trying to find common factors, it might be helpful to think of this as 2 times 5. Okay, since I noticed that I've got a 2 pulled out of the purple one I've got up there. Okay, so now comes the fun part where we get to simplify. Okay, if there's anything within each fraction that can simplify, do it. Or remember, we can simplify on the diagonal. So for example, I noticed this factor of x minus 1 and this factor of x minus 1 can simplify. And like I mentioned, a 2 and a 10 both have a common factor of 2. So that gets to simplify. Okay, and I am just left with x plus 3 in the numerator. There's nothing else to multiply on top. And then in the denominator, I've got an x plus 5 and a 5. I'm going to go ahead and write the 5 first, but it really doesn't matter. Multiplication is commutative. It doesn't matter what order you do it in. And that would be the simplified version. All right, on to question 9. This time we're going to be subtracting two rational expressions. And kind of like when we solved above, we know they need common denominators. Lucky for us, these two already do have common denominators. So to simplify this, I'm ready to just subtract the two numerators. The thing you have to be careful about is we're going to be taking this 5x minus 2 and needing to subtract the whole second numerator, the whole x plus 2. Okay, these have that common denominator of x minus 3, so I'm going to write it as one big fraction. But the thing to make sure you do, especially for subtraction, is to subtract both terms here. Okay, so this is really 5x minus 2 minus x minus 2 in the numerator. Okay, so we'll go ahead and just combine our like terms. A 5x minus 1x gives me 4x. And then negative 2 minus 2 more gives me negative 4. Okay, and this would be our simplified form of that subtraction problem. 4x minus 4 divided by x minus 3. All right, for the last one, number 10, simplify the following rational expression completely. And this time I notice we are dividing two fractions. Okay, dividing fractions is the same as multiplying by the reciprocal. So my suggestion is to start by keeping your first fraction just like it is. Okay, we'll start our simplifying soon, but rewriting this as a multiplication problem. Okay, instead of thinking about this as dividing by 21x to the 5th over y to the 4th, I'm going to multiply by y to the 4th over 21x to the 5th. Okay, and now that it's just a multiplication problem, I can find things that can simplify within each fraction as well as on the diagonal. Okay, so the first thing that I notice in this fraction is x squared divided by x to the 5th. I've got x times x on top and x on bottom, 5 of those. Okay, so 2 of those x's are going to simplify, become 1. But if I had 5 on bottom and I only get to simplify 2, I am left with x to the 3rd power here. Okay, the next thing I notice is on this diagonal, I've got y squared and y to the 4th. Okay, again, 2 of those y's will get to cancel out, but if I'm only canceling out 2, I'll still have 2 left over on top. Okay, the third thing I notice is with my number parts here, 7 and a 21, those are both divisible by 7. I can reduce this, so take 1 7 out of the 7 and 3 7s out of 21. Okay, let's go ahead and see what we've got left, and then we'll check one more time to make sure there's nothing else I have to simplify. So on top, I now just have a 1. My x squareds went away, so 1 times y squared, top times top. 1 times y squared is just going to be y squared. And on the bottom, I took away 2 of those x's, so I'm left with x to the 3rd power. And then I've got times 3 times x to the 5th power. Okay, I'm going to go ahead and write the 3 first. And then if I've got x to the 3rd power times another x to the 5th power, there's one more thing I can do to finish simplifying. I can combine those. Okay, x times x times x, and then times 5 more is going to give me x to the 8th power. Okay, so my final answer is going to be y squared divided by 3 times x to the 8th power. And there is nothing else you can do to simplify those. All right, so hopefully this video is going to help you study and see maybe where your questions are, what you maybe still need some extra practice or help on. There's a couple more versions that you can now try to see, does this make sense? Do I know what I'm doing? And then you can check the answer keys as you go as kind of like a practice test before your actual capstone. Okay, so thanks for working hard. Hang in there.